Hi everyone, and welcome to this edition of Modern CLIs. We are going to discuss together how to write CLIs and how to make them more efficient with the use of TypeScript. So first, a word of introduction about me. I'm Maël, a Node developer. On Twitter, you might find me on the Arcanis handle. And if you follow me there, you will see that I talk a lot about package management. There's a good reason for that, which is that I've been Yarn's lead maintainer for a few years now. And as you may know, Yarn is a huge CLI. We have dozens and dozens of commands, and each of those commands can have its own options. Some of the commands are even just proxies to other commands. We tend to bend a bit what we typically can do with CLIs. And it started to be a bit difficult to use our old CLI frameworks. So when we switched TypeScript, I decided to write something specially tailored to our use case. It's ClipOnion, and we're going to talk a bit about it later. First, a word of introduction about what CLIs used before JavaScript. It all started with one simple C command called getOpt. getOpt got created in the 80s, and before that, at the time, there was no standard. So for instance, you might be familiar with Windows commands that accept a slash as prefix for their options, whereas POSIX systems tend to use a dash. That's the kind of difference that existed at the time. getOpt got created in order to standardize this kind of CLI definition by enforcing the use of a dash. You don't define the prefix, getOpt does it for you. However, the getOpt API is very simple at best. If you check on the screen, you will see that it accepts the arguments to parse, then a descriptor string. This string contains a bunch of letters, optionally followed by a colon, to indicate whether they have an argument or not. getOpt will crawl the list of arguments passed to your program and will check whether they match one of the letters in the descriptor string. If they do, it will yield a value that you will then be able to switch case to find which option it is and do something based on that. This API is very simple, but it kind of does the job, except if you need long option names, since as you can see, this format doesn't natively support long options. The reason for that is simple. POSIX by itself doesn't support long option names. It only supports short options. So when this function, getOpt, got adapted to Bash, it was mostly the same thing. Bash has a built-in called getOpts with an S to differentiate it from getOpt without an S, which is a regular CLI binary. So getOpts with an S is a Bash built-in that just iterates on the descriptor string in order to find all the options that are in your arguments. And for each one of them, it just yields a value that you can switch case. So mostly the same thing as C, except perhaps in a bit less readable because that's Bash. This function got adapted into other languages, like Python, for example, but didn't get implemented in Node. So since it wasn't in Node, people tried to implement their own solution in userland. And we are going to go over those solutions. It was, for our purpose, the second generation of CLI frameworks. So first you have Yargs, which I think many people are familiar with. Yargs just takes the list of arguments and then parses it magically. So for example, here on the screen, you can see that I have my arguments that are passed to the hidebin function in order to strip the first two arguments, which in Node only contains the path of the Node binary and the path of the current script. So it removes those two, then it forwards it to Yards, and Yards detects that, for example, the CLI that I passed contains -- chips, and that it's a number. So it converts it into a number. It also detects that I have passed a distance option, and then same thing, it converts it into a number. Another CLI framework very similar to Yarg's is Minimist. Originally, Minimist was used with another CLI framework called Optimist, but the maintainer of Optimist decided that Minimist was actually all that was needed in order to create CLI applications. So they deprecated Optimist in order to only keep Minimist, which is the very core of the CLI framework, without all the features that you might expect. It's a very down-to-earth implementation, but it's very small. Commander is also another CLI framework that a lot of people in the Node ecosystem have grown accustomed to. Commander has a very different approach to what we can see with Minimist. Instead of parsing everything magically, Commander expects you to declare the option using the option function. So for example, here you can see that I declare 3 options: debugged, small, and pizza type, which all take both a short option name and a long option name, and all have a description. You can also see that the way arguments are declared is by adding anchors into the option description. So here with type, which is different from what we saw with getOpt, where it's just a column that no one reading it would know means arguments unless they are already aware of it. In this case, we have an option that is very clearly defined by just reading the descriptor string, and we know what this code does. So that's an important thing that we were going to keep in mind. What can we say about this second generation? The first thing is that all those syntaxes are very simple. It's easy to get started and write a CLI by using any of Yarg's, Minimist, or Commander. The second one is that they like implicit definition. For instance, both Yarg's and Minimist both accept any option that the user will pass and convert it into a JavaScript object. Since you are not forced to declare the list of options, it makes the thing feel really magical because you don't have to declare anything and you already have your object that just works. Finally, we can see that they have flexible types. If they see that the value that the user passed is kind of like a number, then they are going to assume that it's meant to be a number, and they are going to cast it as a number on the JS side. You won't have to write anything. So all of this is great for beginners and for small applications. But does it actually scale once you start to have, let's say, a professional CLI, once you start to have a lot of comments? From my perspective, it doesn't entirely. The reason for that are multiple. First, unwanted casts. That's actually a pretty big deal. Since they tend to cast the values into the types based on what they look like, it means that in various cases, they are going to make casts that they shouldn't make. For instance, in the CLI that you can see on screen, we just extract a value commit hash from the arguments and pass it forward to git show. So basically, we take a commit hash as parameter and we forward it to git. Because of the implicit cast, if we pass a hash that is actually a good number but that starts with zeros, Minimist will strip those leading zeros from the value because it looked like a number. So the 0 was unnecessary and it removed it. It's the same problem in a lot of different places. For example, if you have true, then it might be parsed into the literal true, but then it's not exactly what the user said. So once you're converting it back, you don't have the right the right type or the right format. So in general, casts need to always be explicit. You want to control the type of the data that you're working with, especially if you're at a conference called TSConf, which means that you care about types. So those casts are not something that you want to have. They usually have ways to disable them, but the fact that by default, the values will be casted from one type to the other is a problem, because it means that you have less control. If you forget to define a type, then you have nothing that will prevent you from using the value, and that's not a really good practice. Another issue are typos. So you have the same program, but this time try to see what's the problem. I think if you take a look, you will see that commit hash got written with a single M. And since I don't have a proper definition of the options I accept, then it's difficult to really notice. So in this case, the argument's commit hash is always undefined because the user is typing it with the correct syntax. You also have the opposite problem. If the user types it with a syntax error, most of the CLI framework that we saw earlier are going to accept it and just turn it into a JS object property, but with the wrong name. And you have also ways to make them strict, so to crash if the user is passing an option that is not explicitly declared in the configuration, but then you lose a bit the magic of those frameworks, and you're starting to enter the land of having to figure out, is that the best framework for me? Because I don't benefit as much from its magic as before. And finally, another problem are forgotten options. So in this case, I have a commander and I declare the command and I parse it. If the user passes small and pizza type, then I pass them to cook pizza. That's all fine. But what is the debug option for? It doesn't do anything. We never use it. Shouldn't we be aware that we are having something that we don't actually use? In order to do that, it's quite difficult because you don't have a good way to say that, oh, debug is not used anywhere in my program. Even if you were using a custom ESLint rule, it would be very difficult to actually check that debug is used. And that's one of the problems with most of the CLI frameworks nowadays. They don't integrate well with the existing tools from the JS ecosystem. For example, with ESLint, we have ways already to say that one values or one property is not actually used in the program. And we should be able to leverage them, but we are not quite able to. This one is interesting. So you might be aware that Yarn is currently now at its version 3. But back in version 1, we used Commander. And as I mentioned, Yarn is a huge CLI with a lot of needs in terms of CLI. For instance, when you run yarn run something, you don't have to put the -- in order to start writing options. So for example, you don't have to run yarn run ESLint -- space -- my option for my option to be passed to ESLint, which is the case on NPM, I think. In order to do this, we had to implement a whole lot of logic on top of Commander in order to make sure that he understood those kind of needs. That became very complicated because at first you start with one behavior like this that you implement as a layer on top of Commander. Then you have 2 such behaviors that you're composing on top of Commander. Then you start to have 10 of them, and it starts to be very difficult to understand what happens. And you have bugs that arise simply because you just have your layer on top of Commander, and your layer is not perfect, and Commander is not perfect. But at this point, it's very difficult to refactor because it kind of works. So if you refactor it, you run the risk of breaking something. It was a huge mess, and that's in large part why we decided that it was worth making our implementation that supported all the features that we needed for Yon 2 and 3. Under TypeScript. So we haven't talked about TypeScript so far. We have just discussed about how to write CLIs using JavaScript. But TypeScript brings interesting features. Here you can see that I'm using yards, and this time I'm declaring every single option. So in this case, I declare that there is an option A that is a Boolean. There's an option B that is a string, and that must be that must be present. We have an option C that is a number, but that also can be called chill instead of C, so long option name. We have a D that is an array of string. E that is a count, so you can pass it multiple times, and instead of being an array, yards will count the number of times E is passed. And you have F, which is one value amongst many. And everything is properly typed because yards does its magic in order to convert this JavaScript dictionary into a TypeScript schema. One thing, though, is that since it can be both sync and async, it's actually a union of this type with a promise yielding this type. But that's not very relevant to the problem at hand. One thing to note is that, as I mentioned before, if we start to declare all of our options, then we use much less of the magics that yards provides. So at this rate, is yards actually the best framework that we could use to leverage TypeScript? I think there are two better options. So let's go see them. Just before I need to mention it, Commander, I think, doesn't still support TypeScript. So I took a quick look before this talk, and Commander, I think, has its own API that is typed, but it doesn't infer the type of the argv based on a definition. And in fact, it would be quite more difficult because, as we saw, the syntax for Commander is by mutating the type of the CLI. So let me just show you quickly. So here you have your program with 3 options, and each of them can actually be on a separate line. And each of them will mutate the program. But at the end, TypeScript has no way to know what will be the final type because other ones might be, other options might be added later. So Commander doesn't support TypeScript. If you want TypeScript, don't use Commander. Anyway, yards does support TypeScript, still with some shortcomings. And came the 3rd generation of CLI framework. So first, I'm going to talk about the one that isn't mine, Oakleaf. So Oakleaf is a very comprehensive framework made by HeroQ that intends to let you declare commands as classes and arguments, a bit like yards, by defining them as a JavaScript object that will then be turned into a proper TypeScript type by using the this.parse function call. It's quite it works really well. It has this whole documentation that declares how to write CLIs. And the reason I'm not fond of it, but we're going to discuss it a bit later when I will bring the second option, is that Oakleaf has a lot of features, too much in my test, because it makes the framework more complicated than it would need to be. For instance, here, you can see that in order to create a CLI, you have to use their generator. In fact, if you go on the website, you will see that at least I couldn't find the way to start an Oakleaf CLI without using the generator. It's not always a problem, but it means that it's more difficult to jump into Oakleaf without being instantly logged in. Something, for example, that I really like in React was that React was one library that doesn't try too much to force your hand around a framework. You just have to plug it in and you can start hacking on it quickly. Of course, then you can have your generators on top of it, like Create React App, but it's really one library. And Oakleaf is really a compounding of library. If you want to have an help message, then you will need to have the plugin for the help. If you want to have a a completion support, then you have to need the plugin for the completion. A lot of things are plugins, and for CLI, I don't think it makes as much sense as for other things. Anyway, there's ClipOnion. So ClipOnion is the library I wrote for Yarn 2 years ago, I think. And that's my first choice, of course. ClipOnion went through a few iterations. The very first iteration was a long time ago. And at this time, ClipOnion was called Concierge, and the syntax was very different. At the time, I thought that if you might remember this syntax from Commander, where you put -- the option name, space, and then you put the argument definition directly within the string. I said that it was really handy, and that's true. I really think that. The problem is that it doesn't integrate very well with the JavaScript ecosystem. For instance, I mentioned earlier that it would be nice if we were able to leverage ESLint to tell us that an option isn't actually used. That's not something that you could do if your option is declared in a string. So instead, I went a different approach with ClipOnion 2, then 3. Decorators. ClipOnion 2 used actual decorators, like the TypeScript decorators. So each option was just a member of a class that was annotated with a decorator from the ClipOnion library. It worked fine, but it had two main drawbacks. The first one was that there was no inference of the types. So for instance, if you were writing a string, then you needed to explicitly write the type of the string inside your CLI class, your command class, in order for TypeScript to see it. ClipOnion 3 changed that in order to use fake decorators. We're going to go over that a bit later as the bonus part, but basically you declared each property and assigned them to a value that will be the value sent by the user. And TypeScript will be able to infer what's the actual value of first arg. What's best is that this syntax works whether you're using JavaScript or TypeScript. So if you want to start your CLI by writing JavaScript without having to set up TypeScript or anything, you can. It will just work the exact same way without you having to set up any transpiler. Whereas when it was real decorators, since decorators are not part of the standard, they needed to be transpiled always. So I really like this new syntax. ClipOnion versus Oakleaf. So remember, everything is always about trade-offs. ClipOnion has less features than Oakleaf. For example, it doesn't support prompts built in, but it does support everything you can ask about CLI parsing, whether it's short option, long option, whether it's proxy option, whether it's array, whether it's comments, multi-segments comments, required comments, everything is supported. It leverages class properties for tooling integration. It means that your code can be more concise and benefits from everything else in your tooling, like ESLint, as I mentioned, but also TypeScript itself.
It's a single package that has no runtime dependencies. So it's very light and it's easy to integrate it within any already existing CLI. And finally, it doesn't require a generator to get started, which is, I think, a really big selling point for me, because I create a lot of CLI for Yarn, but for other things as well. For instance, we create a CLI for my work, and not having to this override when creating new CLIs is really appreciable. Anyway, it will be time to get started to write actually some code, since this is a workshop. So what are we going to do? We are going to write a Yarn CLI. We won't actually deal with the business logic of Yarn, of course, but we are going to build an interface for a CLI for Yarn. It will be fully type checked, so we will be able to quickly check whether we are making mistakes in our code. And for now, we are going to start with those 6 commands. So first, yarn install, yarn config get, yarn add arguments, yarn run, one command, yarn workspace for each run, which is a new command starting from yarn 2, and then the regular yarn without any parameter. This one is interesting. Don't think it's too simple. And finally, just as a little fun bonus, I will show you how to implement CP, which is a command that, even though you might not notice it, is actually quite hard to get right. Okay, so let me open my terminal. So I'm in the tfconf folder. First, I'm going to init a project. We're going to add the TypeScript into it. So I'm using Yarn 3, if you're wondering why it looks like this. So Yarn add a TypeScript, Yarn TSC, I think it's init. Yep. So we have package, we have the tsconfig. Okay, so let's open VS Code. Okay, cool. I'm going to add Companion as well. And I'm going to DLX. Going to install the SDK for VS Code, since I'm using PNP, which is a much faster install strategy than non-models. Okay, so now let's start with index.ts. First, let's check that TypeScript works fine, just to be sure. And here it tells us string is not assignable to type number. So everything is working peachy. I'm going to increase a bit the size of the font. Good. So the first one we are going to implement is yarn install. First, we are going to import CLI from Companion. The CLI class is the base of everything that we will want to do to run actual CLI code. So we're going to do CLI.from an array dot run exits So we don't have the node type, so I will add that quickly. Types node, and now it works. Great. So what I wrote is a new CLI.
it does everything that I could want. So for instance, if I run it, oh yeah, of course. We need TS node in order to be able to run node TS node register here. So what I did is that I declared the CLI, and then I said that I wanted to run this CLI with my arguments and with the default context. So I'm going to go over the context in a bit, but for now, just ignore that. What's important is that I have this empty array. That's the list of the commands that we want our CLI to contain. So the first one that we want to implement is Uninstall. The way it will work is that we are going to import the command class and create our own derived command. Very much like what Oakleaf would request. And here we are going to have an async execute function that just says installing dependencies. As I said, we are not going to bother with everything that is business logic of a package manager. That will be quite out of scope, and I'm not sure we could in the half hour remaining. And here we are going to just pass this command as parameter to CLI.from. This time, so just let me, I will go in the package.json and create a little shortcut because I know that it will be annoying otherwise. Let's call it CLI. Yeah, CLI is a nice name. So here we are going to want to run yarn run dash or ts node register and index.ts. So here, if I do yarn CLI install, class constructor command cannot be invoked without new. So I think this might, yeah, that might be because of this, because it transpiles down into ES5, which is too low for classes. I think it's this. Let's check again. Yep. So this time it tells me that there's an extraneous positional argument. Why does it do that? It's because we didn't tell it that this command was mounted on the install word. So what we are going to do is that we are going to declare a static path plural parameter that contains an array of strings, and we are going to make install. Each command can have multiple paths. So in this case, that's why you see that I have an array of array. I could make other arrays of path, and each path can have multiple words in order to access them. So here, if I run it again, installing dependencies. Cool. So that was easy. That was the first command that we needed to implement. What's the next one? The next one is yarn config get name. So this time we're going to see how to have an argument. So I have my yarn config get command that still extends command, right? I have my async execute, and we are printing getting config value for, we don't know what yet. Let's leave that as a placeholder. And finally, I have my static path, which is config get. See? multiple words because the function can be accessed via long path. And I add it to the config to the command array. Running CLI install still called the right one, and this time writing config get should print getting config value for question mark. So how do we do to declare an option using ClipOnion? We are going to import the option symbol. And we are going to say here that I want an option that will be the parameter that is an option.string. And since it's a class property, I can just access it using this .parameter. What happens? If I try to run this, I will get not enough positional arguments. So ClipOnion correctly detected that there was one positional argument. And if I write foo, it will tell me getting config value for foo. That's pretty nice. Okay, so that's all we needed to do for this. But let's do it a little more complicated. And let's implement also an option that is home. So home, this time, it's not a positional argument like parameter. It's an actual optional option that you can pass with the dash dash. Home lets you in Yarn say that you want the configuration value for the home directory. So here, all we have to do is to say home, and that's an option.boolean. And this time you can see that I made a mistake. TypeScript is telling me that it expects 1 to 3 arguments. It expects a descriptor. Descriptor is basically just the name of the option that we need to implement. So in this case, it would be dash dash home. And if I check, so it still works if I don't have the option, but oh, let's print something. What and what will be this.com. Otherwise, local config value. And this time, so just to make sure that everything works, local config, and let's pass it dash dash home, getting home config value. Okay, just fine. So we have implemented config get. What's the next one on our list? It will be yarn add args. So in order to do that, we are going to have a yarn add that extends from command that has an async execute and that is mounted to the add keyword. Now, what's different from the other option that we implemented with the yarn config get is that this time we can have as many positional argument as we want. So how do we declare that? We just have to say that packages is equal to option.rest. And by doing that, yarn will just allow me to sorry, not yarn. The ClipOnion will just aggregate all the values that follow yarn add, ready for consumption. Installing Decorators. Now, if no, I need to add it, of course, to the array. So now, if I run yarn CLI add foo, it will install foo. If I say foo and bar, it will install both of them. Okay, cool. Something I need to show you. If we go back to config get, we are in tsconf, so we care about types, right? So what if instead of yeah, actually, yeah, you can just see it clearly here. Pick ages as the type string array. It just works. TypeScript has been able to infer that this pick ages here is a string array, because that's what the option.rest function returns. Similarly, here you can see that home is a Boolean or an undefined value, because that's what the Boolean predicate returns for those specific values. And here you can see that it's a string because it's a required positional argument. If I was to make these arguments optional, so that would be by using required else, then the value would become string or undefined. So all the overloads are there so that all the types are inferred by TypeScript. Let's go back to yarn add. Here we are going to add a bunch of flags just to make everything as good as we can. So carrots. Exact, which is and tilde. If you don't know them, those options let you define what type of string should be added to the package.json field, whether it needs to have a caret or to be exactly the version that you are requesting, or if it needs to have a little tilde. And here, if we console log all this, we can see that and tilde. So here we make an add, everything is undefined, and we set them to true with, for example, tilde. Note that options can have default values as well. So for example, here I could make false, false, and false. And then if I was running the command again, we would see that everything is properly initialized. Anyway, next command is yarn run. Yarn run, that extends command that has a static path that is 1, and that has an async execute. This time, we will want to have one positional parameter. So it will be our command, which will be an option that's string, and a bunch of arguments. So for now, let's use rest as we did before. Running this command with arguments and this .args. Let's add it to our array, and this time yarn CLI run foo for the command name and hello world. And it seems to work, so that's fine. That's great. But what if instead of hello world, those are options? So rewrite those two. It should work still, right? But it doesn't. The reason for this is simple. ClipOnion has no idea whether hello and world are part of whatever you want to do with the execute callback, or part of an option that is for the run command, because options can be anywhere in the command line usually. What we are going to do to fix this is that instead of using option.rest, we also are going to use option.proxy. So for instance, here, we have the arguments that have not been parsed. The reason for that is that proxy takes everything that follows when parsing the CLI and just puts them into the arguments array without asking any question. Just like REST, it returns an array of strings. It isn't used a lot, but for example, if you want to make a command that forwards a logic to another command, for example, that's what happens in yarn run, since we are calling a binary and passing it parameter, then you will need to want to use proxy, because they will be options will be forwarded without you having to do anything about it. If we were to use REST, then instead of writing this, it means that our users would have to write this. So with the extra dash dash, which would tell Clipanion that it needs to stop parsing. Okay, so let's put back proxy. Next command on our list is yarn workspaces for each run command args. That's a long command that got created for yarn. Yeah, it got introduced with yarn 2, and that iterates on each workspace you have in your projects and run the specific command. So static path it equal to workspaces for each. It's a little bit verbose, but I like verbose thing. Async execute when they make sense. Console.log executing a bunch of scripts. Yeah, actually I can just copy paste this. And well, it's really just the same as we wrote before. So we have command, we have args, we use a proxy because we are forwarding the call to something else. Workspace for each has a lot of options, and we are going to implement one of them. That will be the topological, which is option.boolean. Again, we need to write this like this. Okay. And we can even give it a shorthand by using this syntax. So if I write yarn CLI workspaces for each run to topological, what happens? Topological is passed as a value of my args. And that makes sense because we are using a proxy, remember? So how can we make it so that this topological will be set instead of this one? It's not in the CLI definition that we can do this, but it's to the user to make a little change. They need to pass topological before the command name. By doing this, it's unambiguous whether topological is meant to belong to the CLI command or to the proxy. Because otherwise, if we leave topological at the end, then it's really just too ambiguous. And Clipanion always resolve it by the safest choice, which is to forward the argument to the proxy, since it doesn't know whether, since otherwise there would be no way to pass an option called topological to the foo script, and it doesn't know whether it's something that we would want to do or not. Anyway, let's keep going. We have no yarn to implement. And this one will be interesting because it will be no command at all. So yarn is interesting for two reasons. I mean, the yarn command is interesting for two reasons. The first one is that when you call it without any parameter, it will yield to yarn install. The second one is that when you call it without parameter that is known, it will go into the run script. So for instance, let's say that I have yarn foo. It will be sent to yarn run foo. And if I have yarn like this, it will go to yarn install. That's difficult to do with most CLI frameworks I'm aware of. But not with ClipOnion. With ClipOnion, it should be fairly easy. All we have to do is to say that yarn install is a default comment. So now if I run just yarn CLI, it installs the dependencies. But if I run yarn CLI foo, it still tells me that something is wrong. There is an extra positional argument that is not supported by yarn install, right? So what I can do is to just go to my yarn run here and also mark it as a default comment. And this time, ClipOnion will be able to see that we are trying to call yarn run foo, even though we are not explicitly saying that we don't need to declare a yarn command that has no argument and then try to forward the argument to something else. No, we just have to say that we have two default commands. The only difference between the two of them is that they have required positional arguments. ClipOnion is able to understand what it means and to properly route the execution to the right one. That's a pretty cool thing. The last command we want to implement, and I'm trying to do it as fast as I can because we are reaching an hour. So it's source, etc. with a def. This one is a bit difficult because for CLI frameworks, because you have any number of source parameters, but then one mandatory destination. The way it's supported in ClipOnion is that, so we are going to have our static path execute. We have our sources and we have our destination. We are going to say that our sources are an option.rest. And we are going to say that our destination is an option.string. And if I remember correctly, by doing this, ClipOnion will check the order of definition. Exactly. ClipOnion looked at the order of the options. So here it's so that rest is defined before the string. And it is able to see that one of the strings, since it's required, will have to be taken from the rest. As a result, without having to write anything yourself, you are able to parse something like this, where you have an infinite amount of source positional parameter and one mandatory trailing positional. That's something that is not quite that easy to write in other CLI frameworks. And something else that you can see is that, let's say here I'm writing CLI CP dest. We have an empty array because REST accepts 0 or multiple. But here we can make it required with a number, so 1. And this time it will be required to pass at least one input to the command for it to work fine. Okay, cool. Let's go back to yarn workspace for each run. So we have the topological option, but it supports another CLI option. It supports parallel, which is a number of parallel job to execute the number of a thread to spawn when executing the for each. Parallel must be a number. If we check here, we see that parallel is still a string. So that's something that we want to address. How do we do that? With another library called Tipanion. Tipanion is a companion library for Clipanion. Oh, sorry. It has a bunch of validators that we can use in order to coerce and validate values. So we have Tipanion. And what I'm going to do is, where is it? It's here. Here, I'm going to set a validator. And this validator will come from the Tipanion library and will be is integer. Is number, sorry. And here, if we go in parallel, we see that the number of the type has changed. Instead of being string or undefined, it's now a number of undefined. Similarly, if we want to remove the undefined, we can just say that it's 1. We need to put it as a string since it will still go through the validator. But if we check there, it's just a number as we expected. So that's how you can enforce types into all of your options. Actually, perhaps I should have insisted on this more because it's quite critical to Clipanion's abilities. You can enforce any types on anything. The Tipanion library, which I'm going to show you a bit, so the Tipanion library contains a lot of predicates. It's a bit like YOP, if you're aware of it, that lets you define everything you want about your options. So for example, you can easily enforce that an option is a UUID. You can enforce that an option is an array of any number of values. And it will be reported by Clipanion as you would expect, without you having to write any more boilerplate code. So let's go back to the slides after all this time. We implemented our yarn CLI. We went through how to use Clipanion. There are some pro tips that I hoped I would have been able to show you, but that are a bit too difficult to show you in the time that we have allotted. Automated documentation. So for example, if I write yarn CLI-h, it will, yeah, if I go here, I can make built-ins, which also comes from Clipanion, and by writing yarn CLI-h, it will show me the definition of all my commands that are documented. But I didn't take the time to document them, so it doesn't show very well. Lazy evaluation means that you can evaluate some require or import directly within the execute block, so you don't lose time instantiating your CLI. Command context, command inheritance, hidden comments, all those things are described in the Clipanion documentation. We have tips and tricks here, and they are all defined. So the documentation is on mael.dev/Clipanion. Clipanion is very comprehensive. It contains a lot of things, and it really helps when writing TypeScript application, because as I mentioned earlier, since all those are just a JavaScript, if let's say I remove this here, if I go back to my TS config, I know that there is one field somewhere, no unused. Maybe it's this. No, it's not this one. I don't remember which one, but there is one option in TypeScript that tells you when you have an option, a parameter that is not actually used. Yeah, it's by setting them in private. Here you can see that sources is declared, but its value is never read. So if you define your option as private, TypeScript will be able to tell you that you're making a mistake. And that's very valuable, because as your CLIs tends to grow, you very often refactor things. And by refactoring them, you always have the risk that you are going to remove an option or add an option and forget to implement it, or forget to remove its logic. Basically, TypeScript really catch a lot of errors that would be very easy to make otherwise. So that's it. Yeah, a quick little bonus to finish. So did you know that you can lie to the compiler? What happens in order to make this inference work is that Clipanion doesn't return actually a Boolean to when calling it. This returns an object, a JavaScript object. Except that this is a JavaScript object is specially handled by the CLI class that we mentioned. It will detect that there is this value, and it will define it as an option. By doing this, it will be able to parse it. And if we go there, in fact, let me show you inside the Clipanion repository. If I go into the command declaration, no, option, into Boolean here, you can see that all those things, for example, here, I return a complex object, but all of them are overriding the return by any value that I want. And by doing this, it means that I get to lie to the compiler by telling it that I will return a Boolean, even though it's not the case. But for the perspective of the user, which is you, it is actually a Boolean. So it's very interesting as approach because it allows you to make decorators that are compatible whether you are writing JavaScript or TypeScript, and that benefits from type inference. Because let's say that, for instance, I would have written something like this. Let's say that I have written option.boolean with this would not have worked. The reason for that is that TypeScript doesn't infer property types based on their decorators. So here, topological would have been any. And it's actually shown here, member topological implicitly as an any type. So I would have had, just like in Clipanion v2, to flag the number, the type here by marking it. which is annoying because it means that I can make a mistake. I could have made a topological string. There are ways to avoid that. I mean, not to avoid writing the type, but to avoid having desynchronizing. But by relying to the compiler as we did, we get to unlock a new syntax that is much more readable than it would have been with decorators. One problem with that is that it is not composable. So for example, let's say that another library wanted to implement their own fake decorators like I did. They would not be able to because this syntax is invasive. It relies on returning a special object inside the topological property that the CLI class will then understand. So it's not applicable in every situation, but it's still nice to keep in mind. Good. So I hope you enjoyed the talk. Both the first part that was a bit theoretical and the last part that was more technical. If you need references, so the repository for Clipanion is github.com/arcanis/Clipanion. The documentation is https://mael.dev/Clipanion. My Twitter handle is Arcanis, so feel free to ask me questions about that. And finally, you can also take a look at Oakleaf, which is also the other framework that I mentioned from the third generation, and which a lot of projects are using successfully. So it's still an option if you really want to. Thank you for being there, and see you next time.